So then, here's my original green graph. Here's the red graph. This goes down 3. So x stays the same. Y goes down 3. My asymptote goes down 3. So as I go to the left, y approaches -3. And as I go to the right, x still approaches -3. For example 6, I see the squared here. So here's my starting function in green. The 2 stretches the y value graph of the graph, and the +4 moves the graph to the left 4. So the vertical asymptote moves to the left 4, and this point 1, 1 now has a y value of 2. This point of -1, 1 has a y value also of 2. Domain and range of the red graph from left to right. It's got to jump over -4. And from bottom to top, it starts almost at 0 and goes up to infinity. Example 7 has a parent graph of 1/x. So that's drawn in green. That graph is flipped, so the green graph gets flipped up and down. Up and down is a y change, and then we shift the graph to the right 3 and up 2. So the red graph is flipped, shifted to the right 3 and up 2. I take each of these points that are special on the 1/x graph and also move them to the right 3 and up 2 after it's been flipped. And I get this point and this point. So the horizontal asymptote gets moved up 2. That's where the y equals 2 comes in. And the vertical asymptote gets moved to the right 3. And that's where the x equals 3 comes in. Now this is different. And so in this case, I used long division, where this gets divided into this. This is the divisor. This is the dividend. And so 1 times x is x, and 1 times -1 is -1. Subtract 3 minus -1, and I get 4. So the quotient is 1, and the remainder is 4 over the divisor. And so hopefully now you see here the 1/x graph. That's in green. The x minus 1 moves the graph to the right 1. The 4 stretches the y value, and the +1 shifts the graph up 1. So let's take our middle first of our green graph, and it shifts to the right 1 and up 1. But this point that used to be here, 1 above the x-axis, is now stretched to 4. The point here used to be at -1, now it's stretched to -4. And then for symmetry, we have these other points. Domain from left to right for the red graph jumps over the 1. The range for the red graph has to also jump over the 1. Because of that, the horizontal asymptote is y equals 1, and the vertical asymptote is x equals 1. End behavior, going to the right, the y value gets closer and closer to 1. Going to the left, the y value gets closer and closer to 1. As you approach 1 from the left, we go down. As we approach 1 from the right, we go up. Just for practice, since the divisor is in the form of x plus or minus something, I can also use synthetic division. And then here are the two coefficients. Bring down, multiply, add. This is our quotient. This is our remainder over the actual divisor. Hopefully, again, you can see this is 1 over x. That's the green graph that I've dashed to begin with. The plus 3 moves the graph to the left 3. The negative flips the graph, and the 2 stretches the graph in the y direction. So there's our flip, there's our stretch, and then this plus 2 on the outside shifts the graph up 2. This plus 3 next to the x shifts the graph to the left 3. So let's do that. Here's our original center at 0, 0. I move it to the left 3 and up 2. This graph used to go up, now it goes down. Here it used to go down, now it goes up because of the negative. And then the 2 on top stretches the y value by 2. So normally I'd have a point of 1, 1 here from the center, but now I have to go down because it's flipped, and I double it, and that's where I get this point. Same thing here, there used to be a point here, flip it, it goes here, double it, it goes here. So for the new red graph, I take my original function, I set it equal to 0, and that's when y is 0, and I'm looking for the x-intercepts. Cross multiply, solve for x. And sure enough, we have an x-intercept of -2. To find the y-intercept, we let x equal 0. These terms go away. We're left with 4/3. And sure enough, the graph hits between 1 and 2, closer to 1, like 1 1/3. Left to right, this graph is always going up from left to right, but at -3 it starts over again, so I don't include that. It is never decreasing because it's always going up from left to right. It's concave up here, the cave goes up. It's concave down here, the cave goes down. Or from left to right, I'm making a left turn as I stay on the graph, and over here, I'm making a right turn as I stay on the graph. So the concave up is from -infinity to -3, and the concave down is from -3 to infinity.